All right, today we're going to talk about linear regression. This is section 5.5 from our book. Now, what we've been doing is we've been talking about scatter plots and best fit lines. And when I had you guys draw a best fit line the first time, I said there's no like one perfect answer, just as best you can try to find the line that fits the points. Now, what we're going to learn today, linear regression, is a way to find the best fit line. Not just like this is probably kind of looks like the best fit line, but the one single perfect best fit line. Now there is a way to do this by hand, but most people don't do it. Usually if you're doing linear regression, it's going to be like a computer program or a calculator that does the work for you. And that's what we're going to focus on today, is how to do that. Now first I want to teach you guys what the correlation coefficient is. Now we know what correlation is. Correlation is how much the points follow a pattern. We can say you have strong correlation if it's like right in a nice perfect line. We can say weak or no correlation if the points are just kind of spread out everywhere. Well, when we do linear regression, the computer is going to calculate a number called the correlation coefficient, and it's going to be called R. Now the correlation coefficient is always a number between -1 and 1. So it's usually like a decimal, either positive or negative 0.7359 or positive 0.24, whatever. You know, a decimal between -1 and 1. Now it tells you two things. Number one, it tells you whether the correlation is positive or negative. So if it's a positive number, you have positive correlation. The points are moving up from left to right. If it's a negative number, you have negative correlation. Points are moving downwards, decreasing from left to right. But the other thing is it tells you how strong the correlation is. So the closer the number is to 0, positive or negative, the weaker the correlation. The closer it gets to either 1 or -1 means stronger correlation. So if you have correlation of 0, it means there's no correlation, the points are just spread out everywhere. If you have correlation close to 1, like maybe 0.9, it means you have positive correlation, the points are moving up, and they're kind of clustered pretty tightly together. If you had a positive 0.1, it means, yeah, they're moving up, but they're spread out a little bit wider. So here's some examples for you. The first one up there on the top left says R equals positive 0.7. And it's positive because you can see those points are moving up. Now 0.7 is a pretty big number. You know, it's not 0.9 or 0.99, but it's pretty big. It's pretty close to 1. That's why you have pretty strong correlation here. All the points are clustered in that little circle right there. Now the second one says R equals positive 0.3. They're much more spread out. You know, now all of a sudden the points are spread out all the way around here. But they still are kind of moving upwards. Like if you look at the circle I drew, it still kind of is moving upwards. Now the third one says R equals 0. Those points are just everywhere. And when R equals 0, you know, you don't even really draw a line. If you did, I would do what they do and just draw a perfectly horizontal line through them. Say there's no real line here. And then the bottom two are the same as the top two, but down instead of up. So right here you have R equals negative 0.7. So again, these points are clustered pretty closely together, but this time they're moving down instead of up. And same for the second picture, R equals negative 0.3. The points are spread out much more widely, but they still are moving downwards from left to right. So that's what the correlation coefficient tells you. Two things. Number one, positive means the points are moving up, negative means points are moving down. But number two, the bigger the number is, the closer it is to 1, the more tightly compact they are. And the smaller the number is, the closer it is to 0, the more spread out they are. So what I want to do today, I told you you can use calculators or you can use a computer program to do linear regression. For the video today, I want to teach you how to do it on Desmos. So the best way to do it, Desmos has linear regression on it. When I'm trying to do it on Desmos, instead of going to Desmos and trying to set it up for linear regression, what I do is I go to Google, I type in Desmos linear regression. You click the first link and it takes you to one that's already set up. All you have to do is type in the X's and the Y's, type in the points basically. So that for me is the quickest way to get there. You know, instead of going to Desmos and trying to set up a linear regression question, just get one already set up for you. Now, after you type in all the points, X and Y, it will give you everything you need. It'll say R equals blank, that's the correlation coefficient. It'll say Y equals MX plus B, that's the best fit line. It'll do all the work for you and you'll just have it. So we're going to do one example for today. We're going to find the correlation coefficient and the best fit line for this XY table right here. And I'm going to show you how to do it on Desmos. So I copied down the XY table. We're going to end the PowerPoint here. I'm going to go to Desmos. I'm going to open it up and show you how to do that. All right, so here we are. And I told you guys the easiest way to do it, instead of just going to Desmos, I'm actually going to type Desmos linear regression. And then if you click the first link, it says statistics linear regression Desmos. It'll take you, instead of just taking you to Desmos, it takes you to one where it's already pre-set up for linear regression. Now there are already some points in here, so we'll just go through and delete those. Start a new table. Okay, so I told you I wrote down all of our points. I'm going to do all the X values first. So it was 1, 4, 5, 7, 9, 12, 15, and 17. And then for the Y values, it was 25, 26, 20, 12, 15, 14, 12 again, and 8. All right, so we have our linear regression. If you kind of zoom out and make it fit, that's what our points look like. And that's also the best fit line. They drew it for us. Now, if you go over here, not on the graph itself, but on the work to the left and scroll down, see what I was saying? It gives you everything that you need. So the first thing I asked you guys is, what is the correlation coefficient? It's right there. It says R equals negative 0.8789, rounded off to 4 decimal places. So number one, it's negative because the points are moving downwards. And number two, it's pretty close to 1. It's negative 0.8789. That's a high number, which means the points are clustered pretty close to that line. And they are, except for one. There's one that missed by a little bit, but that's okay. One of them looks like it's exactly on the line. But most of them are clustered pretty closely around it. That's why we got a pretty high number there. So that's what R tells you. Two things. Number one, positive or negative. And number two, how tightly together the points are clustered. But just as importantly, underneath it where it says parameters, M equals negative 1.02529 and B equals 25.4713. The M is the slope and B is the y-intercept for slope-intercept form. And in fact, it says above, if you look at it, it says y1 and then it has the little squiggle, which means it's about equal to, because we're rounding off decimals, M times x1 plus B. Y equals mx plus B is basically what it's saying. So for that orange line in the picture, which is the perfect best fit line, the slope rounded off is about negative 1.02529. And the y-intercept, I'll slide it up a little so you can see, says the y-intercept is about 25.4713, about 25.5, and you can see that, that's right about here. There's the y-intercept, 0.25.471. So it's giving you, it's doing all the work for you. If you use Desmos and you type in the points for linear regression, it does all the work for you. And it'll tell you what the correlation coefficient is and what the best fit line is. So now you guys know how to find not like kind of the best fit line, but the perfect best fit line. And you also know how to find the correlation coefficient. So what you guys need to know is what the correlation coefficient means. If I give you that number, if I say R equals negative 0.8789, you got to know what that means. But that's basically our goal for today.